2y1 plus y2 greater than equals to 3. 3y1 plus 2y2 greater than equals to 5. So this is the mathematical model which is in the dual form. So we have to solve it to the graphical method. Let's begin. So in the what is graphical method? We find the extreme points through it. So for the extreme points, you need to find out the x-intercept, you have to find out the y-intercept, you have to find out different points through which you can make the line. So this is the equation we have. So 2y1 plus y2 equals to 3. 3y1 plus 2y2 equals to 5. So you see, we have two equations. We have changed this inequalities into the equal form. So you see, these are the two equations we have. So why we have changed? Because so that we can find the x-intercept and y-intercept of these equation. So let's find for the equation 1, let's find the x and y-intercept. For that, y1, y2, y1 equals to 0, y2 equals to 0. This we have to make so that we don't miss any point. So we will be finding this point and that point. So this will be the y1 intercept, this will be the y2 intercept. Okay, so let's begin with the 2y1, in which y1 is 0. So when y1 is 0, 2 in equation 1, 2, 0 plus y2 equals to 3. Okay, so 0 into 2, 0 plus y2 equals to 3. So y2 would be 3. It would be 3. So this is the first point we have found of this equation. This, for the second point, what we do, we have to put y2 equals to 0, y2 equals to 0 in the equation 1. So 2y1 plus 0 equals to 3, and 2y1 equals to 3, and y1 equals to 3 by 2, or you may write 1.5. Okay, so y1 would be 1.5. Now we have found this line would be made because there are 2 points. So we will make a graph, and from the graph we will make first point 0, 3, second point would be 1.5 or 0. Okay, let's move ahead with the equation 2. So in the equation 2, we will be doing the same. Okay, equation 2 is y1 equals to 0. So 0 plus 2y2 equals to 5. So you see, instead of y1 we wrote 0. Okay, 3 into 0, that is 0, plus 2y2 equals to 5. Then y2 would be 5 by 2. We will divide 2 on both sides. Okay, so 5 by 2 is 2.5. It is 2.5. Now, when already you see y1 equals to 0, now we are going for the y2 equals to 0. This is the y2 intercept. The y2 intercept we will put in the equation number 2. Okay, 3y1 plus 2 into 0 to 5. So you see in equation number 2, if you put y equals to 2, y2 equals to 0, y2 equals to 0. So the equation would be like this: 3y1 plus 0 equals to 5, and y1 equals to 5 by 3. What does that mean? We divide 3 on both sides. So 1.67. 1.67. Let's move ahead. So we have found this. Now we can draw, and after drawing that, we will find the intersecting point through equating the equation. Through elimination method, we'll eliminate and find the intersecting point. Okay, so we have a choice: either we find the intersection point first, but we will go to draw first, so that, because there is a possibility that both lines are not intersecting. There's a possibility because the mathematical model can be like that. Okay, let's draw this. Okay, now you see what we have to draw, maximum 3 up till 3 or something. So this 1, this 2, this 3, likewise 1. With the approximation, obviously we don't have a graph, so with the approximation we are going towards it. Okay, so we are done with this. So what are the points we had? So let's write all the points so that we don't miss any. We have y1 comma y2, y1 comma y2, y1 comma y2, y1 comma y2. So with equation 1 we got the equation 1, we got this equation 2. So these were the points, just to make you remember about it. Since we have not given any symbol for it, so you see equation 1, 0, 3, 1.5, 0, 0, 2.5, 1.670. Okay, so these were the points we found. So just to recall, okay, so I have mentioned all the points over here so that it will be easy for you to recall and we don't miss anything. Now we have to draw it 0, 3, 0, 3. This is y1, this is y2. Okay, so y1 is 0 and y1 is 0 and y2 is 3. It is there. y2 is 3. Another one is y1 is 1.5. It must be here. And y2 is 0. So it must be here. So we need to draw it. Now let's draw it. Okay. Now the another points would be 0, y1 is 0, y1 is 0, and y2 is 2.5. So it must be around here. Okay. It is approximation, obviously it is not a definite one. So next point would be y1 is 1.67, y1 is 1.67, y2 is 0. So we will take it over here. Okay. So we have to connect both lines together. So you see both lines are connected now. We need to see in our problem that they were the greater than. They were the greater than. So they must be greater than. Greater than sign will be opposite to this from here. It will be opposite. Okay. So you see over here, the arrow would be this is this. Arrow would be here. Okay. And if you see this line, arrow would be upside. Okay, so this is, so which one is the common region, common feasible area? Okay, let's see it. Why? Because it is greater than. So because of greater than, it is outwards, it is not inwards. If it would be lesser than that, they will be inwards. So we have made it outwards. So you see which one is the common one. Is this a common one? No. Is this a common one? No. So this one is the common one. This one is the common one. And what are the points we had over here? This one, A, B, C, A, B, C. So 3 extreme points we have on this on this common area, or the feasible region we have. Okay, so let's find the intersection point, that is B over here, as I already mentioned B. So for B, finding intersection point or finding intersection point B, what we'll do, we will equate the equations, both equations what we made over here. You see, equate them. How would we equate them? We have to eliminate. We have to use the elimination method. And in the elimination method, what we do, we try to make them equal. For example, we need to eliminate the y2. So for eliminating the y2, we need to make the y2 same so that we can subtract and eliminate. So first we would multiply 2 by equation 1. Okay, multiply 2 by equation 1. So the equation 1 would be 4y1 plus 2y2 equals to 6. 2 to the 4, 2, 1 the 2, and 2 to the 6. So equation 1 has become this one. Now, the previous equation 2 was, which we did not do anything with that. Now we have to subtract and eliminate. So subtract this from this. What will happen? 6 minus 5, 1. This is plus 2y minus 2y, 0. Plus 4y minus 3y, 1. Plus 4y1 minus 3y1. It would become plus y1. So y1 equals to 1. Now we have found the y1 value. We must go for the y2. For the y2, we have to put this y1 value into the equation number 1 again. 2 1 plus y2 equals to 3. What we did, we put the y1 value that is equals to 1 into the equation number 1. 2y1 plus y2 equals to 3. 2 plus y2 equals to 3. So y2 became minus 2 on both sides, it became 1. So what we found, the third point is, we found 1, 1. So another point was, that is the intersection point, it is point B. Or we may rewrite the point A, point B, first we write point B is 1, 1. The point A was 0, 1 point, point A was 1.67, 0. Okay, point A was 1.67, 0. This is that. And point C was 0, 3. So these are the 3 points which are the extreme points. On that we have to find the objective function. So we already know the objective function, that is W equals to 8y1 plus 5y2. Okay, now we will be finding the extreme point, that is A 1.67, 0, B 1, 1, C 0, 3. Now put these values in the equation, these values of y1 and y2 in the equation. So you see 8 into 1.67 plus 5 into 0 would be, you may use calculator for that. So 8 into 1.67 is 13.36. 5 into 0 is 0, so we don't write it. Next is, we have 8 into 1 plus 5 into 1. So you see, we are putting the y1 into y1, y2 into y2. So 8 plus 5 is 13. The next is C. So we put into the objective function, 8 into y1 is 0 and y2 is 3. 5 3 is 15. 8 into 0, 0. 15 is there. So you see, we have found the extreme points of this dual minimization problem. So you see, since it was the minimization problem, so in the minimization problem we have to select the least value, that is 13. 13 is the least value. So you see, the optimum value of z, when z may be the cost would be minimized when the y1 equals to 1 and y2 equals to 1. Okay, so z will have the least value, that is 13. Thank you very much.